Going to discuss about COVID-19 face mask detection using OpenCV, Keras, and TensorFlow and deep learning techniques. There are two phases in this project, as we can see in this picture. First one is the training phase and second one is the testing phase. First one, we load the dataset and train the classifier with Keras or TensorFlow, and then we serialize the face mask classifier to disk. In the second part, we load the classifier again, start the live stream, detect the faces from live stream, extract ROI from faces, and apply the classifier to each face ROI to predict whether mask is wet or not. Finally, we show the results. This is the actual flow of our project. And as you can see, there is a dataset repository. When we have two folders, one with mask and second one is without mask. This is a dataset created using normal images, and we use a custom CV script to add face mask to them, and we used some original pictures also where a person is wearing the face masks in order to get the difference between both the images. And we use the location of the facial structures such as eyes, nose, eyebrows, mouth, jawline, teeth, mustache, etc. to differentiate the images from mask and without, with mask and without mask. Like, we use 10 steps for this project. Like, first we start with an image of a person without mask and apply face detection to compute the bounding box location of a face, and apply this box location and extract face region of interest ROI, and get image of a mask and align it on top of the face properly, repeating the steps for multiple images. Like, we used around 1300 images, with mask 650 images and without mask 650 images. And we used keras and tensorflow to train the classifier to automatically detect whether a person is wearing a mask or not. To accomplish this task, we will be fine tuning the mobile net v2 architecture. We can see that mobile net is nothing but it's a highly efficient architecture that can be applied to embedded systems with the limited computational capacity. It can be a Raspberry Pi or it can be Google Coral, anything. Here we imported a necessary packages and libraries. We already know about the TensorFlow, Keras library, and we used layers like average pooling, dropout, flatten, dense, input model, and we used all this. In basically, these were we are used for the data generator, used for image augmentation and loading the mobile net v2 classifier. Building a fully connected head pre-processing and loading image data. My friend Shivaji will continue.
Thanks, Lokesh, for clearly explaining about the dataset and the architecture used. Now let me explain about the data pre-processing. So this is the directory which we used for storing the dataset, and there are basically only two categories. They are with mask and without mask. Now these are the two empty lists which we created, data and labels. Now for each category and for each image, we first loaded the image, then we converted the image into array, then we pre-processed the image. Now we added the pre-processed image to the data list, and then we added the category to the labels list. These are the two empty lists which we created here. Now using label binarizer, we converted the classes into binary numbers. We used label binarizers because there are only two classes, with mask and without mask, and they can be represented with 0 and 1 or 1 or 0. And then we converted the data list into array, and then we converted the label list into array because the hidden layers will accept only arrays. Now we used test size as 0.2 and the training size as 0.8. You can select whatever size you want. For example, you can select 0.3 as a test size. Now using the image data generated, we generated new images from the existing data by shifting, sharing, flipping, and filling. But this step is not necessary because we already have a big dataset of 1000 pictures. Now we created a base model with mobile net v2 architecture, but we did not include the top full connected layer. Here we created the head model by using the layer functions average pooling 2D, flatten, dense, and dropout. Now we created the model by placing the head which we created here on the top of the base model which we created here. Now for every layer we kept layer dot trainable as false, but we tuned the head. Tuning is nothing but the selecting optimal weights. Now we use the Adam optimizer to compile the model, and we used the metrics. We used accuracy as the metrics, and these are the hyperparameters which we declared at the start of the code. Here we declared the initial learning rate as 1 into e to the power of -4. We took epochs as 20. We can take whatever number we want. We can take 30 or 40, but I took 20. And then the batch size which we selected is 32. Now let me go again here. Now we fit the model here with epochs and validation steps. Now we start predicting the testing set. Here we predicted the index of the label. And now here this is a code for printing the classification report. This gives us a clear understanding about our model. And now we saved our model. I already ran this code. So we got this model here, mask detector.model, here mask detector.model. Now we ran this code to plot the training error and accuracy. After plotting this is output we got.
Now, as we can clearly see, the accuracy, which is in this color, is almost 98-99%. Now here again, make sure we have imported all the necessary packages. Now we have to define a lot of functions and call them eventually. For example, we have defined a function detect and predict mask, and we have passed 3 different parameters for the same. Here frame is nothing but the live video stream. Then we have FaceNet, which is nothing but the face detector model, and MaskNet, which is the mask detection model. We have defined a blob, which will be passed through different networks to obtain the face detections. We'll be passing it through a set of multiple conditions to test. Now here, I have opened the live video stream, and as we can see, I'm not wearing any mask right now. And now that I am wearing a mask, it's clearly visible that it detects the mask and says it's 100%. So basically that's how the model will be working.
This is Ranir and I will be explaining you about the dataset, and I will show you the Flask integration and the final output of our project. So here is our dataset. We have two folders, with mask and without mask. So this is the dataset of with mask. We have approximately 2150 photos. As you can see, we just feed this kind of images into our code, and then we train the model. And coming to the data set without mask, here we have people with just normal faces and stuff, and we feed this to our training model also, so that we can differentiate whether we are wearing mask or not. So now coming to the code, so this is the Flask integration code. So here we import Flask and all the required libraries and stuff, and now we create an app, and we define its root and its index, where we return a HTML file to integrate our code that we've shown previously. And this is the HTML code that we use to create a small web page. The live face mask detection, that's our project title. So we created a button and some headings, and we used a background image to decorate it a bit. So now this is the Flask integrated code, where this was the code that was explained previously. So we integrated it with the Flask code. So we can see this is the Flask part, and this is our code. So here we use this to load the model and integrate it to our web page. As you can see, I'll be running it in a bit. So yeah, as you can see, it's done. Now we have to click this, control click, and this is our web page. So live face mask detection, and camera should be on in a minute. Yeah, it's on now. So as you can see, I'm wearing no mask, so it's showing no mask 100%. So now I'll be wearing my mask. So as you can see, it's showing 100% that I'm wearing the mask. So yeah, this is our work. Thank you all.